Okay, so now that we've talked about mammalian circulation, we are going to talk about the mammalian heart. And just like we went through the pathway of pulmonary and systemic circuit, we're also going to go through the pathway of blood through the heart, including some additional terms that you haven't seen yet. Okay, some of these terms you have seen though. As you know, there are two different types of chambers in a mammalian heart. Two atria and two ventricles. The atria are these smaller areas right here. You can't really see the left atrium very well. It's right here, I guess. And the atria are where the blood enters the heart, and so they serve as the collection chambers for the blood. So the blood is always returning to the heart into the atria. The ventricles are pretty muscular, and they are thick. They have really heavy contractions, and those ventricles are used, they're down here, one right here, one right here. Those are used to pump the blood out of the heart, okay? So they contract a lot more forcefully than the atria do. Atria are for collecting blood, and the ventricles are for pumping the blood out of the heart. I mentioned this before, but we're going to talk a little bit about the vessels that are closely associated with the heart, specifically one at a time. And the first one we're going to talk about is the aorta, which is right here. The aorta pumps oxygenated blood from the left ventricle. And if you remember, the blood that comes out of the aorta is going to go into the systemic circuit. So it's oxygenated blood that goes to the systemic circuit. That's labeled right here. Okay, the aorta. Another vessel we need to learn about is the vena cava. And the vena cava are two vessels, the superior vena cava and the inferior vena cava, that are bringing blood back from the systemic circuit. So after the blood leaves the heart through the aorta and the arteries, goes through capillary beds, the blood is going to return to the heart through venules and veins, and then into the inferior vena cava or the superior vena cava, and then entering the right atrium. So that's deoxygenated blood. The right ventricle, right here, is going to pump the deoxygenated blood through another vessel called the pulmonary artery, which is right here and right here. And that's going to go to the pulmonary circuit, which is going to end up being lungs. And then when the blood becomes oxygenated, it's going to come back into the heart, into the left atrium, through the left pulmonary veins, or the right pulmonary vein. Let's see if I don't really see the right pulmonary vein, but there's a right pulmonary vein as well that would bring, it's from over here. So the pulmonary vein brings the oxygenated blood back into the left atrium of the heart. Okay, and within the heart, there are actually a few valves that are going to prevent the blood from moving backwards. So as you know, the heart pumps, and when, for example, the right ventricle pumps, we don't want the blood to move back into the atrium. Okay, that would be bad. So that would be backwards flow of the blood. So we have all these valves that are around the heart that make sure that the blood keeps flowing in the right direction. They open and close at the correct times to make sure that the blood is flowing where it needs to be. So the two valves that separate the atria and the ventricle, so here's the atrium and the ventricle, here's another atrium and the ventricle. These two valves are called the atrioventricular valves, okay? Pretty easy to remember that name since it's atrium and ventricle. And these are the atrioventricular valves that separate the atria and the ventricle from one another. So there's one on the right and one on the left. And then the semilunar valves separate the blood from the ventricle to whatever the vessel is that's moving the blood out of the heart. So in this case over here, for the right ventricle, this semilunar valve is controlling blood flow from the right ventricle to the pulmonary artery. And where's the other one? Here's the other semilunar valve. It's hard to see. Okay, so here's the left ventricle, and that's leading to the aorta. And so that semilunar valve makes sure the blood keeps flowing into the aorta and it doesn't flow back into the ventricle. Okay, so here I've outlined the entire pathway of the blood through the heart, starting with the return from the systemic pathway, which, if you remember, should be the vena cava, starting with the vena cava. So here, right here, is the inferior and superior vena cava. They're not actually labeled on here, but these are them, okay? The blood flows into the right atrium, goes through the right AV valve, the atrioventricular valve, into the right ventricle, and then it gets pumped through the semilunar valve out into the pulmonary arteries. From the pulmonary arteries, they go to arterioles, then into the lung capillaries, where the blood is oxygenated and the carbon dioxide is released. And then it's going to come back in through venules and into the pulmonary veins. Remember, that was the pulmonary circuit, when it goes into the lungs and the deoxygenated blood becomes oxygenated. So once it comes back through the pulmonary veins, it's going to enter the left atrium right here. And then it's going to move into the left ventricle. This is oxygenated blood now through, oops, I missed the AV valve here, from the atrium, right, the left atrium into the left ventricle through the AV valve, from the left ventricle through the semilunar valve, and then out into the aorta, which is going into the systemic circuit. The systemic circuit, again, takes the oxygenated blood, moves it through a capillary bed of any of the places of the body that needs oxygenated blood, and then after that systemic circuit, the blood is channeled back into the inferior or superior vena cava. So that's the pathway. That's the whole pathway. Now that you have looked at the pulmonary circuit and the systemic circuit and the pathway through the heart, you should be able to essentially recreate this entire pathway on your exam. So that's the end of that little section. I know that that was pretty intense, and we'll try and keep the next parts. There's still a lot of material, but it's not quite as difficult to remember, I think, as the pathways.